ladies and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you for tuning in. What we're going to do today is we're going to take a look at different types of reactions that we are going to encounter in just a general chemistry class. Our first breakdown, and these are going to take up just one singular page. My suggestion to you is you take your notes page and turn it sideways and draw this diagram and add things where it's necessary. But my goal here is to actually get this to fit on one single page. Let's see if I can do this. I'm going to make my arrows now that I'm saying that. Make those a little bit shorter. All right, so my first classification of reactions, we have all these different kinds of reactions. And what it does, ladies and gentlemen, if we can actually start classifying what type they are by looking at the reactant side of the equation, it allows us to have this very powerful predictive power, if you will, to be able to predict what the products are going to be. Because it's all nice and good to be able to mix a couple of things together, but it's even more powerful for us to be able to say, hey, we're going to mix those together, and my prediction is this is what we are actually going to be able to get out of this. And so my first breakdown here is something that we're going to call reduction. Make sure we get that spelled correctly, Mr. Doolin. So reduction hyphen oxidation reactions. And that RxNS is how I'm going to abbreviate reactions. Now, these are commonly referred to as redox reactions. All right, but that's our very first breakdown. And then the other side of this, I'm just going to put not redox. So that's our first breakdown of reactions. Either we're going to have an oxidation reduction reaction or we're not. Now, an oxidation reduction reaction is one in which electrons are actually transferred from one element to another so that there is an exchange or a change in oxidation state. All right, and so that sounds like a lot, but what you really need to understand is that a reduction-oxidation reaction just occurs when I have an electron transfer between two elements in a reaction. All right, now there are a couple of different classifications of redox reactions. The first one here is that we are going to call a synthesis reaction. And a synthesis reaction, the word synthesis means we are going to make. Its general form would be A plus B gives me C. And so notice I've got more than one reactant combining to form one product. And so that's what a synthesis reaction is. My next type of reaction, I'm going to put it right underneath. The next kind of reaction is the opposite. It is called a decomposition reaction, and it's exactly what it sounds like. This is a breakdown where synthesis is composure, it's making, it's synthesizing. A decomposition reaction is a breakdown, and we would see it's the exact opposite, right? So I got one reactant that's going to break down into multiple products, all right? The next one that we are going to mention here is called a single replacement reaction. Now, a single replacement reaction is where one element will replace another in a compound as long as it is more reactive. And so the general form for a single replacement reaction, if I've got AB plus C, would give me, let's make this Cb, we'll assume they're both metals, plus A. And so notice here what happened is the C came over, kicked A out, and so that now A is by itself, and C has replaced it in the compound. Now, single replacement reactions can happen with metals or nonmetals, right? And if it's a metal that's replacing another metal is the way that it'll work, or it'll be a nonmetal replacing another nonmetal, right? Because it's the charge of the compound that's in that, or the charge of the element that's in the compound that dictates what's getting replaced, right? So metals replace metal, nonmetals replace nonmetals. And we have something called an activity series that we have here, and we have to understand that the big thing that I'm not going to write, but I want you to understand here, is that we need a reactivity series to determine if this reaction will actually happen, all right? So it's called a reactivity series. And what that tells us is which elements are more reactive or less reactive than others. So in this particular case, what we would have to say is that C would have to be more reactive than A for this particular reaction to occur. And you need to get that written down, not just C greater than A, because you don't know what that means. All right? And so what that C greater than A actually does mean is that C is more reactive than A, and that's why this reaction will occur. The opposite of that, if C was less reactive, this reaction wouldn't actually happen at all. We wouldn't have any products formed. All right? And then the last type of oxidation reduction reaction that we're going to look at is called a combustion reaction. And the general form of a combustion reaction is some compound plus oxygen gives me, and I'm just going to put products over here because that can vary pretty widely as to what that's going to look like. All right? And so just any reaction, a lot of the times your combustion reactions, we'll call those oxidation or rusting is a very common one. There is another really common combustion reaction that we are going to take a specific look at, and it's called a hydrocarbon combustion. And this is really important to us as people. I mean, this is the way cars work and gasoline is what it is. It's the way our bodies work. Our bodies break down hydrocarbons for energy. And so a hydrocarbon is exactly what it sounds like. And you need this definition. A hydrocarbon is a molecule that's composed primarily of hydrogen and carbon. All right? And so a hydrocarbon combustion is a very specific type of combustion where we get, again, I'm just showing a type of hydrocarbon here, plus oxygen. And what's unique about this is it always gives me the same two products. It gives me carbon dioxide and water. All right? And so a hydrocarbon combustion is a very specific type of combustion, and it will always give me the same two products. All right? Okay. Let's see if I can get the other side over here. And that's it for my reduction, oxidation, or my redox reactions. There's 4 different kinds there that you're going to have to be able to recognize. And again, it's really important to recognize them so that when we get into actually predicting products, you'll be able to do that. Now, my not redox, these generally fall in a double replacement category. And we call them double replacement because unlike a single replacement, now I've got 2 different parts or molecules or compounds or elements that are replacing each other, right, inside of molecules. So everybody's got a partner and everybody switches partners here, all right? There's primarily 2 different kinds of double replacement reactions. I've got acid and base reactions, and then I also have what I'm going to abbreviate as PPT, right? And PPT stands for precipitate, right? And so I'll talk about the precipitate reactions first. And generally what happens here is I get an insoluble product form. And so I've got generally what I'm going to say is aqueous plus aqueous produces some solid product. Now I think this is a good time for me to jump back up here top and let's go over our states of matter. S stands for solid. AQ stands for what we're going to term as aqueous, and what that means is that it's dissolved in water, all right? A G is a gas, and so these are states of matter, and my L, that's my liquid. And so those are my 4. So I have essentially liquid plus liquid makes a solid product, and by definition that is a precipitate reaction. Now, the only solubility rules that you're going to need to know here is that group 1 metals are always soluble, right? And nitrates are always soluble. These are the only solubility rules that I'm going to hold you accountable for. So if your compound has any one of those in it, it's going to be soluble, right? And so we can start to recognize what forms on that product side and predict that, looking for solubility based on, hey, what does not have group 1 and what does not have nitrates. Be sure you notate that and just don't write those down. Now we're going to take a look at acid-base, and I'm going to use up the rest of this space here. Acid-base gets split into 2 different categories. I've got what's called Bronsted-Lowry acids and bases, and then I also have what's called Arrhenius acids and bases. Now, Arrhenius defines his acids and bases as H plus is my, or an H plus donor, let's put it that way, is my acid, right? And an OH minus donor is my base. And that's the definition of Arrhenius, and this would fall under, like an example of this would be hydrochloric acid plus sodium hydroxide. I would recognize that as an acid-base reaction immediately because I've got an H and an OH in there. All right, and I would recognize that as an Arrhenius acid-base reaction. Now, Bronsted-Lowry is a little bit more of a broad definition of what acids and bases are. And Bronsted-Lowry, the way he defines his acids, is still H plus donor. Those are acids, just like the Arrhenius. But now my bases are H plus acceptors. And these are my bases. So an example of this would be like HCl plus NH3. And I'll go ahead and write the reaction out here. And that would give me NH4 plus Cl minus. And so notice the ammonium picked up a hydrogen there. The Cl donated a hydrogen. And so we can identify our acids and our bases there. All right? Okay. So these are all the different kinds of reactions that we're going to be working with over the next couple of months in chemistry. You do have to get to the point to where you'll be able to identify all of them, ladies and gentlemen. We've got some tricks in class that I'll show you how to do, or really quick ways to identify these. We'll also get a little bit further in depth into what these reduction-oxidation reactions actually are and how to definitely 100% identify them. All right, but if you can identify the 4 here, you'll actually be right along the road of being able to identify redox reactions properly. All right. If you have any questions, make sure you got them down. I'll see you in tutorials for those. Otherwise, I will see you in class.